Hello there. Today, we are here to introduce you to our programming language Matcha. I am Punit Shukal and my team number is 17. My team members are Ekta, Sahil, Mustaqim, and me. Talking about Matcha, it is a programming language that we have developed that's designed to make math intuitive, engaging, and accessible to everyone. Matcha is not just another programming language, it's a tool built with purpose to simplify math and make it fun. So, what exactly is Matcha, do you ask? At its core, Matcha is a math focused language that helps users solve equations, practice problems, and visualize concepts. Inspired by games like Nerdle, it aims to blend the logical structure of programming along with the creativity and fun of solving math puzzles.
Hello, so today I'll walk you through the structure of the R programming language grammar. I'll explain how grammar is defined in programming, how ANTLR helps in automating parsing, and how Matcha grammar is designed to support key features like loops, conditions, and expressions. So first of all, what is grammar in programming? Grammar in programming defines the rules that a language must follow. It's like a blueprint that helps validate the structure of your code. So in Matcha grammar defines how we write variables, loops, and expressions. Tools like ANTLR take this grammar and generate parsers, making it easy to build a compiler or interpreter. So I'll walk you through the key elements used in this grammar. First up is program structure. First few lines of this program structure is high-level structure of a program with program consisting of block that contains declaration commands and an end marker. This establishes the overall organization of a program written in the language. Then we can see declarations. The declaration section defines how variables are declared, including the syntax for constant and variable declarations, along with required identifiers and value. Proper declaration of variables is crucial for the language to understand and operate on the data. Then we can see command. The command section lays out the different types of statements and control structures available in the language, such as assignment, if statement, while statement, and others. This is the core of the language functionality as it defines how the program logic is expressed. Then we'll see expressions. The grammar also specifies the structure of expression, including terms, factors, and Boolean expressions. Expressions are the building blocks for more complex operations and calculations within the language. Then matrices is also used. The grammar includes definitions for working with matrices, including the syntax of matrix elements, rows, and multi-statements. This suggests that the language likely has support for matrix-based operations and data manipulation. Then there comes identifiers and numbers. So here the grammar defines the rules for constructing valid identifiers, variable names, and numbers, which are the fundamental building blocks for representing data in the language. So next I'll tell you why grammar is important. There are several reasons. In ambiguous syntax, by providing a formal specification of the language syntax, the grammar ensures that the code is written in a way that is easy to understand, it's clear. This helps prevent errors and ensures consistent interpretation of the code. Next comes language design. The grammar reflects the design decisions and capabilities of the programming language or domain-specific language. This defines the set of constructs and features available to the developers, shaping the way they can express their ideas and solve problems. Then it also ensures extensibility. The grammar can be modified and extended to add a new features or capabilities to the language. This allows the language to evolve and adapt and change requirements overall time. Then the files that are generated are lexer files, parser files, listener and visitor files. I'll give you a brief overview what these files show. So lexer files define how input text is tokenized. Then parser file define syntax rules and how tokens combine to form statements or expressions. listener and visitor files. Its event-driven trigger actions when visiting parts of the trees. Visitors explicitly travels the tree and execute custom logic for each node. And intermediate files are like .interp and .tokens, store metadata about tokens. .class files compile Java bytecode from .java files.
Furthermore, for the implementation, we are making use of ANTLR, known as another tool for language recognition. It is a powerful tool for building parsers, interpreters, and compilers. It allows developers to define the syntax and structure of a language using grammar files, which are simple and intuitive to write. Once the grammar is defined, ANTLR generates the lexer and parser code needed to interpret and process input text according to the rules one specifies. One of its standout features is its ability to generate code in multiple languages like Java, Python, and JavaScript, making it highly versatile. With ANTLR, you have the power to turn complex language processing tasks into manageable, streamlined solutions. So, moving on.
Okay, hi. My name is Mr. and I'm going to give you the brief overview of the installation and execution of the language Matcha. So first of all, it is built using ANTLR and built around Java, so we're gonna have to have both of them installed on our system. So we don't explicitly need the ANTLR environment setup. We can just copy paste the files from the extracted folder, extracted download, and just take it from there. But we're gonna have to have a Java environment setup on our system. So first of all, let's just get those things done. I'm just gonna go ahead and copy the ANTLR file to our folder, and let's just go one by one through all the things that we're gonna be needing. So first of all, it comes with a grammar, which is a master.g4 file. So let's just start with that one. As we have already discussed about the master.g4 file, I'm not gonna go ahead and talk about that and explain about it again. So let's just copy the grammar file here again, which should be here again, yeah, which is here. So let's just copy the matcha.g4 file, which is an ANTLR code, which closely follows the DCG explained earlier. So this is the file we're going to be needing. So let's just start with that one. So first of all, we're going to have to compile or generate the lexer and parser for the grammar, which is going to be done using this command, which is just a basic ANTLR command. So that's how the lexer and parser are going to be generated. But for the execution process, we're going to be needing the visitor class, as we are going to be using the visitor class. So we're going to have to have explicit code for like command for that one as well. So we're going to go ahead and execute that as well. So the visitor class is also generated. So now we have base listener, matcha lexer, parser, and visitor as well. So these are all the source files that we're going to be needing. Then again, the project starts with, like, there is a driver code which is going to handle everything from taking the input to providing the output. So give me a minute. So the main file is going to look like that. This is a driver code, which is I'm going to explain to you in a brief, which is, first of all, it checks if the input is there, which is obviously needed for the execution process. Then it is going to check if the extension is proper. Then it doesn't do that much. It's just going to create an instance for the lexer, create an instance for the parser, lexer for tokenization, parser for creating a parser tree. It will generate a parser tree, and for our sake, it is going to just print a parser tree as well. So let's just go ahead and do that for now. It's not getting complete. Okay, 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 so let's just go ahead and start from here again. So we're gonna be having a driver code, which is a main, then we're gonna be having a executor code, which is main.parser. So we're going to paste both of them in the main source folder. So let's just go through them one by one. So as I've already discussed, this is the code to check if the input is there, which is extremely necessary. Then this is going to check if the extension is proper, which is .matcha for our name of our language. Then it is going to create instances for the lexer, which is going to create tokens. Then instance for parser, which is going to create a parse tree. This is the line for printing the parse tree, basically. Then it is going to create an instance for the main visitor, which is our executor class, which is going to be fed the parse tree generated by the parser. And this is just the driver code. This is the execution code, which is going to have all the functions for all the like necessary actions which are going to be there, like a declaration. This is a visit declaration function, which is going to go through all the declaration statements in the code, then assignment, then print statement. These are the basic statements. Then then we'll go, and this is the plus plus operator, then plus and minus operator, which are going to distinguish between strings and integers. So plus plus is going to concat this string, only plus is going to be adding the integers, and minus is going to be subtracting the integers. Then for the multiplication and division as well. So these are the codes for these are the functions for executing the parse tree generated. So let's just go ahead and compile both of these. Command for compiling all these codes is going to be this, which is just a basic compile command for uh, compiling all the classes, all the jar files created while compiling the matcha.g4 and visitor matcha.g4. So it is going to compile all the things which are there. This is base listener, matcha, lexer, listener, parser, and visitor. And this is the driver code, and this is the execution code. So let's just go ahead and hit enter and run. So for the like the presentation purpose, let's just go ahead and get a sample test code, which is going to look something like this. So this is the sample test code, which, as we've already seen the grammar, it follows the grammar, it has everything. The declaration are done at the start of the program, which is very necessary because there is not a declaration statement mentioned throughout the program. Then there's going to be if condition, while loop, for loop, then basic print statements. The assignment is there, and this is going to be string manipulation, which is string concat at the moment. So let's just go ahead and copy that one as well to the main folder, and let's just go ahead and try to run that code. So as we have already discussed, it is going to generate a parse tree which looks like this, which will be fed to the main execution program, and it is going to generate the outputs for all the like functions provided there. So that's all for the installation and how to execute the given program and create a setup environment for the Matcha. Thank you.
Hi everyone, I'm Sahil and today I'll show you how Matcha works by executing a test case. I'll walk you through the steps involved, including generating lexer and parser, compiling the code, and later executing it to get a concrete output. You can access all the files involved, including the grammar file, the Java file, as well as the test cases in our GitHub repository, as you can see over here. So now that we are done with the introduction, let's start by taking a look at the main.java file, the grammar file, as well as the test file, which contains several programming constructs. These include variable declaration, arithmetic operation, if-else statement, loop, string manipulation, etc. Now that we have the test file, let me walk you through the commands I'll run to process and execute this code. All the commands that I'll use are present in the readme file, which you can find in the GitHub repository. I'll copy these commands first in the command prompt, and after that I'll explain each of them individually. So starting with the first command. So this command generates the lexer and parser based on the matcha grammar file. Coming to second command. This generates the visitor class, which will later help us traverse the parse tree and execute the program. The third command compiles all the necessary Java files, including the lexer, parser, and the visitor class. The fourth command basically compiles all the Java files and the main.java file as well. And coming to the fifth command, as you can guess, this executes the main class, which processes the input file test.txt. The output is the parse tree, as you can see over here. I can explain the parse tree briefly. For instance, the root node is program, and the block nodes are the begin and end, and the commands in the test file, like assignments, print statements, conditional loops, string manipulation, are represented as child nodes in the trees. For instance, if I were to pick something at random, As you can see, a C is being assigned over here as A plus B, where A and B are taken as individual, or A and B are broken down into individual terms. Coming to the output, here the first number which is printed is C, which is the sum of A plus B, where A is 10 and I think B was 5. The numbers after that till 30 from 20 are due to the while loop, where C is being incremented by 5 each time. This was followed by the C being decremented by 1, and finally you can see the variables A, B, C and the result. In the end, you can see hello world, which is the combination of two strings hello and world, as you can see from.
So, in conclusion, Matcha is more than just a programming language. It's a gateway to making math accessible, engaging, and interactive for everyone. From solving equations to visualizing problems, Matcha bridges the gap between mathematical intuition and computational efficiency. With simple syntax, robust features, and potential for future growth, Matcha is poised to transform how we approach math learning and problem solving. Thank you for exploring Matcha with me. I'm excited for what's to come.